Okay, this is chapter 6.1, course practice. Consider the sequence un, which is defined recursively by un is equal to 4un minus 1 plus un minus 2. Recursively means it gives you un, but it's defined as the element that is before it. That's what recursive means. Okay, so they give us u1 is 2, u2 is 5, they're asking for u4. Anytime you see recursive, you have to work your way up. So you can't find u4 directly. Before finding u4, you need to find u3. Okay, so let's find u3. u3 would be equal to 4 times u2, right? Because n minus 1, if n is 3, 3 minus 1 is 2, plus u1, right? Because 3 minus 2. You substitute, so 4 times 5 plus 2 is equal to 22. So that's u3. Now can I find u4? Yes, I can. So it's going to be 4 u3 plus u2 is equal to 4 times 22 plus 5. So you get 93. Very easy. Question 2. Consider the sequence un, which is defined explicitly by un is equal to 8n plus 11. What's the value of n if un is 171? Very easy. I can't think of questions easier than this. You're going to do 8n plus 11 is equal to 171. Other side, 8. 8n is 160. N is 20. Question 3. Consider the sequence un defined by un is equal to n squared plus 5n minus 6. Then what's u5? Very, very easy. u5 is equal to 5 squared plus 5 times 5 minus 6. You're going to get 25 plus 25, 50 minus 6, 44. Again, extremely, extremely easy. Question 4. They gave you un is equal to n squared minus 3n minus 5. U what is equal to 35. We want to see n squared minus 3n minus 5. When is it equal to 35? So just equate to 35. Again, it's quadratic, so you have to move everything to one side. So you're going to get minus 40 is equal to 0. You can factor this, or if you have a calculator, you can solve, but you're going to get, when you factor n minus 8, n plus 5 is equal to 0. The correct answer is not 1, no? It's 8. Okay, so you're going to get two values, n equals 8, n equals negative 5. If it's written, you show this is rejected. Why? Rejected. Because it's negative. N cannot be negative. You start from 0, 1, 2, 3, 4, 5. But this is n equals 8. Okay? Question 5. What's the value of sigma 5k minus 2? Very, very easy. I don't think I have to explain this. You can start by doing 5 times 1 minus 2, 5 times 2 minus 2, 5 times 3 minus 2, 5 times 4 minus 2, 5 times 5 minus 2, because up until 5, you're gonna get 3, 7, 15 minus 2, 13, 20 minus 2, 18, and 25 minus 2, 23. This is not 7, it's 8, my bad. Since we're saying sum, you can add up all of this, okay? And when you add them up, you get 65. An alternative method to solving this is splitting up the sigma into 5k minus sigma 2. Obviously from 1 until 5, 1 until 5. Over here you can do 2 times 5 is 10. And here it becomes 5 sigma k from 1 until 5. And then, sigma k is equal to n plus 1 over 2. So here it's just 5, 6 over 2, and you have the 5 outside. Okay? Minus 10. You get 15, 45. Hold up. Yeah, which is 75 minus 10 equals 65. This also works. Okay? This saves me time because I already know the rules. I have them memorized. Like, if you know the rules, this is easier to do. Saves you time. If you don't know the rules, obviously you're gonna do all this. Okay? Question 6. Consider the sequence un defined by un is equal to 2 un minus 1 minus un minus 2. U1 is 1, U2 is 3, then U5 is what? Again, you have to work your way up to U5. You can't go directly to U5 when you have recursive definitions. So you have U2, so you go to U3. U3 is going to be equal to 2 U2 minus U1, which is equal to 2 times 3 minus 1. Just substituting the given, huh? Which is 5. Then U4 will be equal to 2 U3 minus U2, which is equal to 2 times 5 minus 3, which is equal to 7. Then U5 will be equal to 2 times U4 minus U3, so it's going to be equal to 2 times 7 minus 5, which is 9. Question 7. What is the rule for the partial sum Sn of the series 3 plus 5 plus 7 plus 9? So we have a sum, okay? Obviously the sum involves sigma. Anytime you're asked for the sum and you have a series or a sequence, you need to find the rule of the nth term of the sequence. And remember, an is equal to dn plus b, where b is equal to a1 minus d. So what's d? Obviously, it's 2, right? So an is going to be equal to 2n plus b. So what's b? We need to know what it is. How do you find b? It's always a1 minus d. So 3 minus 2, which is equal to 1. So you're going to get an is equal to 2n plus 1. So when we say we're finding the sum, we're doing sum of 2n plus 1 from n is equal to 1 up until n. They use I instead of n because well, it's easier over here. So it's more professional when using sigma to use I. That's just like how they do it. And when this dot 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 means and it keeps on going forever. So since it keeps on going forever, we end it at n. But if they stopped it over here at 9, you know this is the 4th term, so you'd end it up at 4. Okay, but they didn't. They put dot dot dot, which means it continues on forever. Okay. That's it for 6.1. How much? I think we should do 6.2 as well. Okay, we're on 6.2. an is an arithmetic progression with a24 minus a8 equals 176. What's the common difference? So remember, whenever you see a something minus a something, you use this formula. An minus am is equal to n minus m d. An in this case is a24. Am is a8. And they gave us that this an minus am is equal to 176. So you can just substitute this all with the 176. Is equal to n minus md. What's my n? 24, right? What's my m? 8. D we're trying to find. When you divide and solve, you're going to get 176 equals 16d, and then you're going to get d is equal to 11. Okay, very easy. Question 2. The sum of 3 consecutive terms of an arithmetic progression is 24, and their product is 312. What is the value of the largest of these 3 terms? Okay, this question is actually a very nice question. It needs a bit of thinking, but after I think 10 minutes of solving, I finally figured it out. The sum of 3 consecutive terms is 24, and their product is 312. Keep in mind it's an arithmetic progression. They're saying what's the largest of these 3? But let me tell you how to start. You have 3 consecutive terms of an arithmetic progression. An arithmetic progression, let's say you start with the value of n. Okay? You know that the value after that will be n plus the common difference. And the value after that will be this value plus another common difference, right? So actually it's n plus d plus n plus 2d, right? Equals how much is the sum they said? 24. Let's simplify this a bit. We have a lot of n's and d's. You're going to get 3n plus 3d is equal to 24. You can factor out 3. You're going to get n plus d equals 24. Divide by 3 on both sides. You're going to get n plus d is equal to 8. So we actually figured out what this number over here is. What else do we know? We know that the product is 312. So we know n times n plus d times n plus 2d is equal to 312. This is where you need to use your brain a bit. We know that the middle number is 8. We know that. We figured it out. What do we know about n? Isn't n 8 minus d? Isn't it just 8 minus the difference, right? Because it comes before it. And isn't n plus 2d just 8 plus a difference? Yeah? And this is equal to 312. We're multiplying. You can multiply this out, but once you multiply, you're gonna get 64. You're gonna get first, before multiplying, I'm gonna cancel 8 with 8, huh? It's gonna become 39 over here. You're gonna get 64 minus d squared is equal to 39. To expand this, you can just do a minus b times a plus b is equal to a squared minus b squared. You can use that or just expand normally, it's fine. Anyway, to solve this, you're gonna get negative d squared equals negative 25. If you take this to the other side, divide by negative, you're gonna get d squared is equal to plus minus root 25. So plus minus 5. So we have two solutions. D is equal to positive 5. D is equal to negative 5. Try it out, okay? Try positive 5. Try negative 5 first. 8 minus 5 is 13 times 8 times 8 minus 5, that's 3. Okay, try it out. 13 times 8 times 3. You should get 312. I think for the product it doesn't matter. But if you try positive 5, it should also work. You're gonna get the same thing. But over here for the sum, I think you don't get the same thing. Let me see. 8, then 8 minus 5. Let me try negative. So for the sum, it should equal 24. So when I do this over here, instead of, let me put this like this, you get 24. So you get negative 5 and 5, they both work if you try them both. Okay, so it can be either any of these. We don't have any more information, so they didn't ask us what's the difference, what's n, what, we don't care. Okay, they only asked us what's the largest of these three terms. Obviously 13. Why 13? You had 8 minus d, 8 plus d. Regardless of whether you use plus 5 and minus 5, you're still gonna get 3, 8, 13, or 13, 8, 3. We don't care what the order is, just what's the largest. That's why they asked what's the largest. Okay, question 3. The first term of an arithmetic progression is negative 4, and the 14th term is 61. What's the sum of the first 20 terms? Sn, they give us, what did they give us? They gave us a1 and they gave us a14. We know Sn is equal to n over 2, a1 plus an. And we also know Sn is equal to n over 2, 2a1 plus n minus 1 d, right? Like, we're looking for the 20 terms. So 20 over 2, 2 times a1 is negative 4, no? Plus n minus 1d, so 19d. Why 19? Because, well, 20 minus 1, right? N minus 1. Anyway, we need d. You can't work without having the d, right? Again, not like that. But anyway, you need to find the d. How do you find d? Given any two terms of an arithmetic progression. Remember, I always told you, to find d, you use this formula. When do you use this? When the two terms aren't after each other. Obviously, they're not going to make it easy and tell you a1 and a2, because then you can just subtract them. They gave you a1 and a14. So using this formula, a14 minus a1 is equal to 13. Why 13? Because 14 minus 1, no? a14 is 61. a1 minus, a1 is negative 4 equals 13d. You get these equal to 65 divided by 5. You get these equal to 5. So over here you go 20 over 2 is 10, negative 8 plus 19 times 5. You get 95 minus 8, 87 times 10, 870. It's correct. Question 4. The 32nd term of an AP is 301. The common difference is 9. What's the first term? You have many ways to do this. You can use that an is equal to a1 plus n minus 1d. You can use this. You can use an minus am is equal to n minus 1d. n minus 1. I'm gonna use this because we're using this for many questions. Okay, you can use this as well. an minus am. We have a32. We're trying to find what? First term, so a1 is equal to n minus 1, so 32 minus 1 d. Let's substitute. A32 is 301. We're trying to find a1 equal to 31 times d is 9. So you're gonna get 31 times 9, and then 301 minus this answer, you get 22. So a1 is equal to 22. Question 5. And am I talking? Yeah, okay. What's the sum of the first 20 terms of an arithmetic progression? This is it. They didn't continue it for me. Sn is equal to n over 2 a1 plus an. Do we have the 20th term? No. So it's better to use Sn is equal to n over 2 2a1 plus n minus 1 d. Right? Type n over 2, 20 over 2. 2a1, so 2 times negative 9, plus n minus 1d, 20 minus 1, so 19 d. What's the negative 4 minus 9 is what? 5. Right? Minus, not plus. Negative 4 minus 9 is 5. So 5. So you get 95 minus 18, that's 77, 95 minus 18. Okay, you get, it's correct, 770. Okay. Question 6. An arithmetic progression has first term 3, so a1 is equal to 3. The nth term is 83, and the 3nth term is 251. Find that. Type, okay. Okay, this one, it's kind of tricky as well. Again, you need to use your head. You need to use simultaneous equations. Our given is a1 equal to 3. Our given also is an is equal to 83. And our given is a3n is equal to 251. Okay. What do we know? Okay, we need to find n and d. What mixes n and d? What formula? You have an. Obviously, when you're using two terms, always use an minus am is equal to n minus m d. Right? We're gonna use this formula. Let's start with an and a1. So an minus a1 is equal to n minus 1 d. Right? Because I'm substituting the letters. We know an is 83. We know a1 is 3 equals n minus 1 d. Type. You get 80 is equal to n minus 1 d. That's the first equation. The second equation, you can use also this formula, but with an and a3n. Why am I doing this? Because I know that the n's will cancel with each other. You'll see now. So a3n minus an is equal to n minus m d. Look, a3n we know is 251. an is 83 equals n minus md. N is 3n, right? M is n. 251 minus 83 is 168 equals 2nd, right? You divide by 2, you're gonna get 84 is equal to n times d. This is my second equation. Can't I substitute and say that n is equal to 84 over d? I can, right? But actually, I'm not going to do that. I'm going to say that d is equal to 84 over n. And over here, I'm going to substitute what? D as 84 over n. So we're going to continue over here. 8 is equal to n minus 1. By the way, you can use n is equal to 84 over d عادي. But why I don't want to do that? Because then you're going to have to subtract by 1. That's too much work for me. I don't want to do that. Okay, 8 is equal to n minus 1 times d, which is 84 over n. Distribute, you're going to get 80 is equal to 84n minus 84 over n. How do we get rid of this n? We multiply by n on both sides. So it cancels here, and here you have 80n. So 80n is equal to 84n minus 84. You're going to get that 4n is equal to 84. You're going to get n is equal to 21 as in the answer. Type. What's the common difference? we know that d is equal to 84 over n. So d is equal to 84 over 21 equals 4. That's it. I'm saying that's it, I know it was an easy question. Question 7. The third term of an arithmetic progression is 12 and the 10th term is 33. What is the 35th term? Okay, this is very easy. You have a3 equals 12. You have a10 is equal to 33. They want a35. Always you need the d, right? You can't solve without having the d. You need to use, how do you find the difference if you have two terms that aren't after each other? Use an minus am equals n minus m d. An is 35, or no, 33, sorry, minus am is 12 is equal to n minus md. 10 minus 3 d. Solve for it. This is minus 12, huh? You're gonna get 21 is equal to 7d. d is equal to 3. Now can I find the 35th term? Of course I can. You know that a35, you can use any formula. You can use an is equal to a1 plus n minus 1 d, or you can use an is equal to dn plus b. You can use all of these, but all of these require a1, because here you need a1 here, and here you need b, which requires a1 aslan. So I'm not going to use any of these. I'm actually going to use I'm going to use this formula again over here. Okay, so I'm going to say that a35 minus, I don't know, you can use a3 or a10, whatever. I use a3 is equal to n minus m d. a35, we're trying to find it, minus a3, which is 12, equals n minus md, so 10 minus 3 times 3. So a35 is equal to 7 times 3, 21, 21 plus 12 is the, whoa. Why am I using 10? Okay, it's not 10. It's 35 minus 3. Because we're doing n minus m, and n in this case is 35. I don't know why I put 10. So 32 times 3, that's 96, plus 12, 108. Yes, 108. That's it. Okay, 6.3 geometric progression. It's 12 questions. It's 11:53. I want to get it over with. The first term of geometric progression is 7 over 2 to the power of 6 with common ratio 2. Then the ninth term is what? You know that any gn is equal to g1 times r to the power of n minus 1. So g1 is 7 over 2 to the 6 times r, which is 2, to the power of n minus 1. 9 minus 1. Okay, do it on your calculator. Let's do it. 7 over 2 to the power of 6 times 2 to the power of 8. Oh, no. Hold up. 2 to the power of 8. 28. Question 2. Tara invests 3,000 at the end of each year and an interest of 4% compounded annually. What is the accumulated capital at the end of the 7th year? Okay, for this one, you need to use, it's geometric progression, obviously, because every year is 1.04 times, let's say, capital of the previous year. Why? Because it's increasing by 4%. Okay, so your R is 1.04. Okay, not 0.04. Because if it's 0.04, that's how much it gained, but I don't care about this. It's 1.04. Okay, because 1.04 is the 3,000 plus the 4%. That's what I care about. So my R is 1.04, and I want to find accumulated capital, so I want the sum. Okay, what's the sum of geometric progression? It's g1 times 1 minus r to the power of n, right? g1 times 1 minus r to the power of n over 1 minus r, right? Let's do it. g1 is 3,000 times 1 minus 1.04 to the power of 7 over 1 minus 1.04. And you get 23,694.8. To the nearest unit, it's 95. Question 3. Consider the number pattern 0.02, 0.2 to 200. If the pattern defines geometric progression, what's its ratio? Obviously, you're multiplying by 10. يعني a monkey can solve this صراحة. Question 4. If a geometric progression G9 is 1 over 72. G13 is 18. Then what's G17? Okay. There are many ways you can solve this, but the first thing I want to do is find R. The same way with arithmetic you need D, for geometric you need R. How do you find R? You know Gn over Gm is equal to R to the power of n minus m. So over here G13 over G9 is equal to R to the power of 13 minus 9. 18 over 1 over 72 is equal to R to the power of 4. Just do it on your calculator. 18, 72 will go up, times 72. You can do it on your calculator, but I like doing it fast. Then you want to find the fourth root of this, right? So fourth root of this, you're going to want to do over here. Fourth root of answer, you get 6. So R is equal to 6. Now to find G17, I can use G1 times R to the power of n minus 1. But I don't have G1. So what do I know? I know that Gn over Gm is equal to R to the power of n minus m. So I can actually use G13 and G9 over here. So I can say G17 over G13 is equal to R to the power of 17 minus 13. So G17 over G13 is equal to R to the power of 4. So G17 over 18, because G13 is equal to 18, equals R to the power of 4, so 6 to the power of 4, which is 1296. Cross multiply. 1296 times 1, 8. 23,328. Another way I got, but I don't want to confuse you because it doesn't work every time, is actually between G9 and G13 is 4 terms, and then between 13 and 17 is also 4 terms. So you can actually do this. You could say G13 over G9 is equal to G17 over G13. This is just something I realized. You can do it if you want any. But anyway, question 5. The numbers 2, 5, and x are the first 2 terms of geometric progression. What's the value of x? Obviously, if it's geometric, you need to know the ratio, right? X is just the ratio times 5. What's the ratio? 5 divided by 2 is 5 over 2. So x is just equal to 5 over 2 times 5, right? So x is equal to 5 over 2 times 5, so it's 25 over 2. What's the sum of the first 10 terms? Sn is equal to G1 times 1 minus r to the power of n over 1 minus r. So G1 is what? 2 times 1 minus r to the power of n, so 1 minus 5 over 2. You could say 2.5 to the power of n, which is what? 10 over 1 minus r. Do it on your calculator, let's do it. 2 times fraction 1 minus 2.5 to the power of 10 over 1 minus 2.5. You get 12,714 to the nearest unit. Question 6. What is the sum of infinity of this series? So they want S infinity. You know S infinity is G1 over 1 minus R. What's G1? 1. What's R? 1 over 2 divided by 1 is 1 over 2. So you can keep dividing and checking, but you're going to get that R is equal to 1 over 2, right? That's how you check the ratio. You just divide the second term by the first term. So 1 over 1 minus 0.5, because 1 over 2 is 0.5. You're going to get 2. Question 7. The first 3 terms of a geometric progression are 2x, 2x minus 4, x plus 1 in this order. What are the possible values? What are the possible values of x? Over here, we want to find x. In a geometric progression, you know, here to here you multiply by r, here to here you multiply by r. A very important rule to know, it works all the time when you have 3 consecutive terms, is that second term, g2 over g1 is equal to g3 over g2. Because you know, g2 over g1 is just equal to the ratio, and g3 over g2 is equal to r. Anytime you divide 2 consecutive terms, they equal the ratio of the geometric progression, right? So since all of them come after each other, this divided by this is equal to this divided by this. And ultimately, when you divide these, you get what? The ratio, right? Anyways, let's cross multiply. When you cross multiply these, 2x minus 4 times 2x minus 4. You get this when you expand it. You can use a minus b squared, which is a squared minus 2ab plus b squared, or just expand normally. You guys are grade 11, so it should be very easy to expand. 2x times x plus 1 is 2x squared plus 2x. Take everything to one side. 2x squared minus 18x plus 16 equals 0. 2 outside. X squared minus 9x plus 8 equals 0. Factor, you can cancel the 2. You're going to get x minus 8, x minus 1 equals 0. You know how to factor. So you're going to get two solutions, this and this. Okay? Which value of x does the series of the given progression converge? What's important here is converge. A geometric series converges when r is in between 1 and negative 1. So basically when r is a decimal. Why? Because when r is a decimal, as you go to infinity, the numbers keep on getting repeated. You know, you're adding by very, very small numbers, because a decimal to the power of like 50 is a very, very small number. So that's why we say it converges. No chance, you're barely adding anything. So we need to know for which value of x is the value of r a decimal. So let's try this one. Okay, 2x minus 4 over 2x. We know when we divide them, we get the ratio. Let's plug in 8. 2 times 8 minus 4 over 2 times 8. So you get 16 minus 4, 12 over 16, which is divided by 4 up and down. You get 3 over 4, which is 0.75. So 8 is correct. Let's check 1, just in case. 2 times 1 minus 4 over 2 times 1. You're going to get 2 minus 4, negative 2 over 2, which is negative 1. Is it a decimal? No. Which one's a decimal? 0.75. For which value of x was it? 8. Easy. What's the sum to infinity of the convergence series? Now we want to find the sum of infinity. You know, the sum to infinity is equal to g1 over 1 minus r to the power. Just 1 minus r, sorry. No power. g1 is 2x. We're talking about value of x is 8, right? So 2 times 8 is g1 over 1 minus r, so 1 minus 0.75. You're gonna get 16. Yeah, you're gonna get 64. Question 8. The sum to infinity with geometric progression of common ratio is 16. The sum of the first two terms is equal to 7. What fraction is equal to the fourth term of the progression? Again, another question where you need to use equations and whatever. So the sum to infinity is 16. So s infinity is 16. And what's the s infinity? It's g1 over 1 minus r. Okay, so we're going to take this as equation 1. Sum of the first two terms is equal to 7. What's the sum of the first two terms? It's g1 times 1 minus r to the power of n. What's my n? 2 terms, so squared over 1 minus r is equal to what? 7. This is equation 2. You're going to need to simplify these two, okay? Someone's going to come here, he's going to tell me this is equal to this. And you cancel these two. If you told me this, if you wrote this on your paper and I was correcting, I would spit on your paper, okay? This is, you're not allowed. This is a difference between two squares. Isn't one a square number? Yes. Isn't r squared a square? Obviously, yes. And we know you can rewrite a squared minus b squared as a minus b, a plus b, right? So 1 minus r squared, I can actually rewrite all of this. This 1 minus r squared, I can turn it into 1 minus r, 1 plus r, over 1 minus r is equal to 7. Now can I cancel? Yes. So what's the difference now? 1 plus r is left over. If you did the stupid shit by doing 1 minus r, 1 minus r, you'd have 1 minus r left over, and that's completely wrong. So we're left with this. Can I substitute g1 with something? Yes, I can. We know g1 is equal to 16 times 1 minus r. So over here, I can substitute g1 with 16, 1 minus r, and you have 1 plus r left here, equals 7. If you expand these, you're going to get 16, 1 minus r squared is equal to 7. Take 16 to the other side, you're going to get 1 minus r squared is equal to 7 over 16. You're gonna solve this, you're gonna get r squared is equal to 9 over 16. So you're gonna get r is equal to plus minus 3 over 4. How do you check which is which? You go back here. Okay, or not here, you're gonna go here. Okay? Actually, no, it can work for both positive and negative. Because if you take r as negative 3 over 4, g1 is going to be equal to 16 times 1 plus 3 over 4. Because it's 1 minus, but minus minus. So you're going to get 16 times 1.75, which is 28. So g1 is 28. What are they asking? The fourth term. g4 is equal to g1 times r to the power of n minus 1. Now we got 28, right? So you're going to do 28 times r, negative 3 over 4, to the power of n minus 1. So 4 minus 1, which is 3. One second. I just realized you're going to get the wrong answer. I just reread the question. They said positive common ratio. I didn't see that, so negative 3 over 4 will definitely be wrong. I was just doing this to see, if it's correct. So you can skip this, and directly over here, you're going to say r equal to 3 over 4, because it's rejected, the negative value. Right? So, for r equals 3 over 4, g1 is equal to 16, 1 minus r. Right? So 16, 1 minus 3 over 4, which is 4. What do we want? The fourth term. So g4 is equal to g1 times r to the power of n minus 1. So 4 times 3 over 4 to the power of, is it 4? 16 times 0, yeah, 3 over 4 to the power of 3. When you do this on your calculator, you're going to get 27 over 16. Easy as. Question 9. Given that p, q, and r in this order are 3 consecutive terms of a geometric sequence, and q is equal to r to the power of 4, fill in the blanks. Okay, this question, صراحة, it's kind of weird. If you have a better way to solve, please let me know. But you have p, q, r, such that q is equal to r to the power of 4. So instead of q, I'm going to write r to the power of 4. Okay? From r to the power of 4 to get to r, what did I do? I divided by r to the power of 3. So also over here, I'm dividing by r to the power of 3. So p is actually what? R to the power of 7, right? So since p is equal to r to the power of 7, if you want to write r in terms of p, you have to do the 7th root on both sides. So you're going to get 7th root of p is equal to r. That's it. Second one. I can use the first one to get to the second one. Okay, I know r is equal to the 7th root of p. What is r equal to? R is equal to the 4th root of q from the given, right? If you do the 4th root on both sides. So over here, I'm going to write 4th root of q is equal to 7th root of p. But don't forget, I'm trying to write it in terms of q, right? Whatever, like I want to make q alone. So to do that, I need to do power 4. So q is going to be equal to 7th root of p to the power 4. When the power is less than the index, it goes inside. Okay? So you're going to get this. Question 10. Inshallah, these questions aren't like this, صراحة. Given the sum to infinity is 32 and its combinations are, what is A1? Okay, this is nice. This is petite. Sum to infinity is G1 over 1 minus R. So 32 is equal to G1 over 1 minus 0.75. So G1 is going to be equal to 8 if you do the math. Question 11. What fraction in lowest terms is equal to the 8th term if the first term is this and its common ratio is 3 over 2? Very easy. Gn is equal to G1 times R to the n minus 1. So G8 is equal to 2 to the power 4 over 3 to the power 5 times R to the power of n minus 1. 3 over 2 to the power of 8 minus 1. All on a calculator. 2 to the power of 4 over 3 to the power of 5 times 3 over 2. Whoa. Times 3 over 2. You get, oh, times r to, I forgot to put the power. Times to the power of 7, no? Because 8 minus 1. 9 over 8. Question 12. What is the value of 90 plus 30 plus 10 plus dot dot dot? Dot 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 means to infinity. And by the way, they say that if the sum does not exist, enter 999. Sometimes the sum might not exist for infinity, because the only time you can get an infinite sum is if it's a converging series. When is it a converging series? When r is between -1 and 1. So first find r. 30 divided by 90 is 1 over 3. 10 over 30 is 1 over 3. So your r is 1 over 3, which is in between 1 and -1. It's a decimal, right? Now you know it's converging, so you're not going to enter 999. So you're going to actually do the sum to infinity. How do I know it's to infinity? Because it's dot dot dot. Okay, so G1, which is 90 over 1 minus 1 over 3. Use our calculator. 90 over 1 minus 1 over 3. 135. Thank you so much for watching, and good luck in your exam.